think for that's LBSS, right?
Yeah, next week, that will be May 26th. It will be only 30 minutes.
It's
That will
about what,
be
Mister? That's the basic computer exam, I think, like that.
this multiple choice
Ah,
based on our
okay.
topics.
Ah, okay.
Okay, so based on our topics, multiple choice.
Okay, Mister.
Can you see my screen?
Yes, Mr.
Yes.
Yes.
All right, so good afternoon, everybody. Welcome to our class today. And I guess you had a long leave, right? You were having like 4 days to 5 days vacation. So now you are fresh, maybe, yes? After your Eid and after meeting your friends and family members. And of course, after eating special food during Eid, yeah? So how was
Yeah.
your Eid? It was nice. Did you go somewhere? You did not go
It's okay,
anywhere?
Mister. Alhamdulillah. Yeah. No, just stay at home to be safe.
Okay. So your first exam will be like this only. It will be 30 minutes. Same with quiz 1, 2, and so on, like this only. So that will be based on the topics, of course, that we have. So that will be from topic 5, 6, 7, 8, and 9 until here. Permutations and combinations. So we finished already topic 5, 6, and 7. We will now have the decision making using probabilities. So I'm going to start with the basics on probability. Then I'm going to proceed to the problems. We go to decision tree and then we go to permutations and combination. This is what we're going to have today. So I want you to review all the topics that we have because your exam is fast approaching. That will be next week. Yeah, so your first exam will be next week, 26, and the take-home exam will be 27. So I'm going to have the revision on Sunday, 23. So you still have a lot of time. Yes, because 26 is the uh, exam. This is only computer based. This will be like 15 questions or 10 questions and multiple choice usually. And you know how to do that because we have a lot of practice exercises there. For example, like this, quiz 1. You just have to click and answer. Yes, and then finish the attempt. Submit. You know how to do this one, right? Okay. So let's proceed to the basics on the probability. Before we're going to proceed to the problems, let's first have an introduction. Let me see if I can write something. Okay. All right. So what is probability? It is the measure of the likelihood that an event will happen, will occur. That's the meaning of probability. So occur here, of course, it means happen, right? I cannot write properly here. It means happen. Now, in other words, it is the chance. that something will happen, how likely it is that some event will occur or will happen. So usually when we talk about probability, we are just looking at the possibility usually. Okay, it's more on possibility. And of course, it is uncertain. So when we say possibility, we are not sure whether it is really going to happen or not. We are uncertain. We are not sure. But somehow we have the what? We have the percentage. We have some values. Just give me one moment. Someone is sending a message to me. Amir. I think Amir is sending a message to me. He cannot attend the class today. Okay. Where is coming from? It's coming from the email. Okay. Right. So let's continue. So as I said, when we talk about probability, it is the chance only that something is going to happen. And we are always uncertain. So that is why in some other textbooks, probability is defined as the measure of uncertainty. It is the measure of uncertainty because we are not certain whether it is really going to happen or not. That is why in some cases, the government, okay, predicted that it's going to rain, for example, that is going to have heavy rain, but it did not happen. Yeah, because we are uncertain. We are, just having our calculation based on the values or the data that we have, but it might not happen based on some other factors also. But at least we have some figures, we have some percentage. So sometimes we can measure a probability with a number like 10% chance of rain. This is what I'm talking about. Okay, and sometimes they say it's like 99%, and we are waiting and it did not happen because it is uncertain. It's just like prediction. Yeah, it's like prediction only. I don't know why I cannot write something here. So it's just like a prediction when we say probability. But we are using some values, we are using some formulas to identify these measures. And in some cases, we use words such as impossible, unlikely, possible, even chance, likely, and certain. For example, when you say it is unlikely to rain tomorrow, that means the chance is very less, unlikely, okay, to rain tomorrow. Let's see some approximate values of these words. So impossible, this is like 0 or close to 0, but usually when we have the values, impossible means 0 or 0%. Please take note that the lowest probability is 0 or 0%, and the highest in decimal or fraction is 1. In percentage, the highest is 100% because we multiply by 100 to get the percentage. So 1 here times 100 equals 100%. Okay, so let's have unlikely. Unlikely is around 25%. Yeah, 1/4, 0.25, 25%. So around this value, we say unlikely. Even chance is equally likely. That is 50%, around 50%. We say equally likely or even chance, 50-50. Likely is around 75%. So you can use the word likely. Usually when people use the word likely, it means that there is a high possibility that is going to happen. When you say it is likely to rain tomorrow, that means you are, saying that there is a high chance of rain tomorrow. Certain is also called as sure event. Sure, because it is 100%. So certain and impossible events occur in reality. Let me give you an example. So assuming we have 50 students in the class and all students are girls. So what is the probability of getting a girl if you're going to pick one student? For example, we have 50 students in the class. And assuming that all the students are girls. So we have 50 students and all of these students are girls. So if a student is picked, what is the probability that it is a girl? Of course, it is 100%. Yes? 100%. Right? Because all the students are girls. We don't have boys. How about P boy? What is the probability of getting a boy? It will be 0 over 50, right? Or 0%. So P of boy is an example of impossible event. P of girl is an example of certain event. Certain or sure event. Okay, we have here examples of probability. One is acceptable, 50%. Yeah, 0.3%. One half, because one half is 0.5, is less than 1. Anything that is less than 1. Okay, but not less than 0. Because the lowest is 0. We don't have negative. 8 over 9 is less than 1. 40% is 0.4. 75% is 0.75. 1.2% is very less. Okay, 13 over 14 less than 1. 197 over 200 is also less than 1. Now here, these are examples of values which are not probabilities. -1. We don't have any negative. 150%. We don't have any probability bigger than 100%. 1.3 as a number because it's greater than 1. We don't have any number in probabilities greater than 1. 3 over 2 is 1.5. Yeah, it's more than 1. 9 over 8 is also more than 1. 140% is 1.4. 101, 1.2, negative by 5.2 is not a probability. Okay? So did you understand from where and until where are the allowed values? Guys? So it is only from, if this is our line, this is 0. It is only from 0 to 1. So we don't have values less than this, and we don't have values greater than this. This is in terms of decimal and percent. This is 1/2 or 0.5. Okay. So let's now talk about mutually exclusive events. When I say mutually exclusive events, this means that these events have no common elements. No common elements. We don't have intersection. So no intersection. This is the symbol of intersection. Okay. For example, our elements of event A are 2, 4, 6. And the elements of event B are 1, 3, 5. There is no common element, right? We don't have the same elements. They are different. So these are examples of mutually exclusive events. They don't intersect. So no intersection. Guys, is this clear to everyone? Mutually exclusive events. Can you hear me?
Yes, Mr. Reeves.
Okay, so
Yes,
mutually
Mr.
exclusive events, no common elements. Okay, let's have another example. This is a die. When I say die, it means what? 6 sides. Yeah, we have 6 faces. It's like a cube. Yeah. So a cube is an example of a die wherein we have 6 faces. If we have 2 or more, we call it dice, D-I-C-E. This is if we have 2 or more. If we have only one, we call it die, D-I-E. So if a die is rolled, what is the probability of getting an odd number or an even number greater than 2? So if we use the conjunction or, we are going to use plus. Yeah, especially if you have mutually exclusive events wherein we don't have intersection, plus only. If there is an intersection, we have to subtract the number of elements of that intersection. So the first step in solving any problem involving probabilities is to find the sample space. When I say sample space, this is the set of all possible outcomes. Okay, set of all possible outcomes. So let me write it here. Set of is here. Okay, set of all possible outcomes is the sample space. Now, what is the set of possible outcomes when you talk about one die? If it is one die, what are the possible outcomes? We have 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4 until 6, because we have 6 sides or 6 faces. Now, what are the odd numbers from 1, 2, 3, 4, 5, 6? The odd numbers are what? What are the odd numbers? 1, 3, and
5.
5. So how many number of
3.
odd? We have
3.
3. Okay. And how about even numbers? What are the even numbers? 2.
2, 4, 6.
Okay, so the number of even is also
3.
3. How about even numbers greater than 2? Because that one is the question. Even number greater than 2. What are the elements?
2.
4
4 and 6.
and 6. So how many? There are only two. Okay, do we have any intersection between these two? Odd numbers and even numbers greater than 2? Is there any intersection?
Yes.
Common
Yes.
elements. Do we have 1, 3, 5, and then the other one is 4, 6?
No.
5.
None, yeah? We don't have any intersection.
Greater
So
than 2.
if there is no intersection, we are just going to add. So the operation is there. So if it is OR, we are going to add only because no intersection, mutually exclusive events. Because the first event is about odd numbers. Odd numbers are 1, 3, 5 in this list. And even numbers greater than 2 are 4 and 6. As you can see, we don't have common elements. So we just add. So the number of odd numbers, 3, total is 6. So 3 over 6 plus even numbers greater than 2, we have 2 over 6. So the answer is 5 over 6. So usually in the exam, I need the decimal and the percent. Okay. So what is the value in decimal?
Mr. It is 0.83333.
0.8.
3.
Okay. So that is 5. You understand why this is 6 here? The formula is this one. The probability of an event is equal to the number of that event divided by the number of sample points. So we have 6. Our n of s is equal to 6. So that is why we have over 6 here and over 6. That is n of s. So the number of elements in the sample space. And n of e, that is what we are talking about. For example, the first event is about odd number. We have 3. The second event is to talk about even number greater than 2. So we have 2 over 6. Yeah, so the answer is 5 over 6. So 83.33%, very good. So these events are mutually exclusive events because no intersection. See, there is a space in between. 4, 6, 1, 3, 5, no intersection. Okay, so this one is very clear. Okay, let's have another example, problem 2. So we have here the patients, middle-aged patients, we have 52. Young patients, we have 59. Old patients, we have 100. The total is 211. So our n of s equals 211. Immediately, you have to look at the sample space and the total. Now, if a patient is randomly selected, when I say randomly, that means what? Everyone has the equal chance of being selected. We don't cheat. That's the meaning of randomly. For example, we have a box. We put the names of the people inside. Yeah, we don't select whichever we want. We are going to mix all the names. Yes, and then pick one without cheating. That's the meaning of randomly. Every element has the equal chance of being selected. So assuming we have 52 middle-aged patients and 59 young and 100 old. Okay, so we are going to select one patient randomly. What is the probability that the patient selected is old or middle age? So the word or is there. Now in this scenario, we don't have intersection. Why? Because middle age are different groups, young different group, old different group. So there is no overlapping. Yeah. So mutually exclusive events. So very simple, just write 100 over 211, the total, plus the middle is 52 over 211, right? Equals 152 over 211. And then use your calculator. Okay? So we have 72.03% as our answer. Do you have any question here?
No, mister, it's clear.
Okay, how about the probability that the patient is not young? This one. What do you think? When it is P not A, the formula is equal to 1 minus P of A. This is what we called as complementation rule. Okay, complementation rule. RULE. We always use 1. 1 is 100% minus the opposite of this. Opposite of not A is A. So P not A is equal to 1 minus P of A. So therefore, when we say P not young is equal to 1 minus P of young. Okay? So that is always 1. 1 minus young, 59 over 211. Okay? So of course, it will be 72 point something or 72.03% multiply by 100. Okay, so do you have any question here? Did you understand?
Mister, can you go again, please?
Hmm?
On B, can you go again?
See, not young. The formula is here. A here is any event. So we are talking about not young. So it will be 1 minus P of young. How many young do we have? 59. So not young is the opposite, 1 minus the opposite. So it will be 52 and 100. This and this, right? So 1 minus 59 over 211, it will be 0.72 something. Masen, for example, I say what is the P of not old? What will be the answer? P not old. It will become 1 minus what?
Yeah, it will be
1 minus P old, right?
yes.
So 1 minus?
1 minus P, 59.
No, old.
Oh, okay.
Okay, so that
100,
will be.
100 of
Did you
divided
understand?
by 200. Yes, yes, yes.
So when I say P not middle age, what will be the answer? P not middle age. It will become what? 1 minus P middle age. So 1 minus
59.
52 over
52 divided by 200.
211. Sorry. Times 100. Okay. 100 outside. Let me rewrite that.
You have a dog, mister?
Hmm.
You have a dog?
No. What happened?
I heard some dog barking.
Really? Maybe from other students. I have fish here, no dog. I have fish.
Okay.
So 1 minus P middle age. I'm struggling with my pen today because I'm using my computer and I don't know. It's not configured here. So this will be 1 minus 52 over 211. Yes? Of course, open and close here times 100. You know how to get the value, okay? This is just additional because the question is this. So the answer is this one. Did you understand this problem?
Yes.
Okay. So we call this as complementation rule. This is what we called as complementation rule. And that is always one there. This one is always 1 or 100%. Okay, now let's talk about not mutually exclusive events. Okay, what's the meaning of that? When I say not mutually exclusive, we have intersection. For example, we have standard deck of cards. There are total 52 all in all. Why? Because we have 13 hearts, 13 diamonds, 13 clubs, 13 spades. And of course, you know this, especially the boys, because usually you are playing cards, right? Without the joker, okay? So NS equals 52, all in all. We have 13 hearts, including the ace and diamonds also. Yeah, so we call this as symbols. Yeah, we have 4 symbols, the hearts, the diamonds, the clubs, and the spades, or we call this as the suits. Okay, now aces and kings, these are example of mutually exclusive because they don't have common elements, they don't intersect. Aces are different, kings are different. But when you say hearts or kings, we have the intersection. Because if you're going to draw a line, yeah, vertically and horizontally, hearts and kings, there is an intersection. That is king of hearts is here. Okay, because king of hearts belongs to hearts and it belongs to kings also. So they can be both. So these events are example of mutually exclusive, but we add not or we use none. So in some textbooks, it is called as non-mutually exclusive events. Or we say not mutually exclusive. So the word none is there. Because there is what? because we have common elements. Sometimes only one, sometimes more. In this case, there is only one, and that is king of hearts. Okay, so the formula will change. The formula will change. What will be the formula? So let me write the formula here. If we have intersection P of A or B, it will become P of A plus P of B minus the intersection. Okay, this is if we have intersection. Okay, the other one is, of course, without intersection. This is only P of A plus P of B. So I gave you two examples of this without intersection. A while ago, I gave you two examples, right? This one about the patients, and the other one is about this, the die. Okay, now let's have an example where we have intersection. A card is chosen randomly. We're going to pick one card from these 52 cards. What is the probability that the card selected is a king or heart? Now we know that we have 4 kings, so 4 over 52. Heart, we have 13. From ace to king, 13 over 52. And the king and heart, and here is the intersection. Okay? So please take note that and here is the intersection. There is 1, so 1 over 52. So the answer, king or heart, the probability will be 4 over 52 plus 13 over 52 minus 1 over 52 because we have intersection. So we subtract the number of elements in our intersection. So the total will become 16 over 52 or 30.769%. Okay, so do you have any question here? Any question? Guys, do you have any question here?
Not for me, Mr.
Okay, now let's have here our table. You must know how to complete the table. So a class has 25 males and 10 females. Where are we going to put this value in this table? Who can tell me? Anybody? We are going to put these values here. Yeah? Total of males 25, females 10. What is the total? 35. Out of these, 5 males and 3 females are expats. Where are we going to put 5 and 3? Guys? 5 males and 3 females are expats. Where to put this? Here, right? 5
Yes, mister.
and 3. Total is what? 8. Yeah? Now, how about this one? What are we going to put here? How many locals then? It's not mentioned in the problem, but how many? How to get the values here?
20.
Yes, why 20?
It's the remainder.
Yes, here is 7. So what's the total?
27.
If you're going to add this, the total is 35. If you're going to add 25 and 10, it is also 35. So we call this as cross tabulation. Yeah, or we just say cross tab. Can you please mute your mic? There's an echo. Okay, so we call this as cross tabulation or cross tab because the row total is equal to the column total. If the row total and the column total are not equal, something is wrong. You have to check. 8 plus 27 is 35. 25 plus 10 is 35. Now you have to find what is the probability of getting a male if a student is selected. Female, expat, local. So how many males do we have? So please take note that our N of S is 35. This is the overall total. So P of male is 25 over 35 and P of female is 10 over 35. Expat is 8 over 35 and local 27 over 35. Please take note that if you're going to add, the total should be 100%. Okay, for the row, and for the column, the same 100%. Okay, so we call this as marginal probabilities. When I say marginal, these are the rows and the columns. Yeah, rows and columns. So that means you have to get the probabilities of the rows, males and females, and we have the columns, expats and locals. Okay, so let's now proceed to our problem. This is only introduction. Right. We will now have the problem here. You can also open this one, decision making using probabilities. So we're going to start with number 9, exercise 9 and 10. So we have two exercises there. The solutions are there already. Exercise 9, exercise 10 problem 1, exercise 10 problem 2a. Okay, so I will start with exercise 9. This is the Word file and this is the PowerPoint. Okay, so I'll be using the PowerPoint, although all the problems are here. Okay, this one. All right, so this will be part of your final exam. So I will not be using the Word file. I'm going to use the PowerPoint, so it will be easier to present. Exercise number 9. We are going to apply our knowledge in probabilities. Okay. So decision making. So our topic is all about decision making using probability. That is why I discussed first introduction of this. Otherwise, you will not understand this one. Why? Because we are going to use probabilities to decide. Okay, and this is very, very important. So we will be using expected monetary value. So we are going to look at how we can use probability in order to help us. Aid is help in decision making. So intuition should now help to explain how probability can be used to aid the decision making process. For example, suppose we are considering launching a new product on the market. So we are planning to launch a new product on the market. So we conduct a pre-launch questionnaire And 86, for example, out of 100 respondents say that they would buy our product if it was on the market. So assuming that we distribute 100 questionnaires, okay, and 86 of these people responded that they're going to buy our product. They would buy the product if it was on the market. So this can be translated into the following. The probability that it will be successful, product successful, is 86 over 100. Why over 100 here? Why over 100? You remember our formula? P of E equals N of E over N of S. S is the total. Yeah, this is our total. So what is the total number of people here? 100 respondents, right? And 86 of these people said that they would buy the product if it was on the market. So the probability, the chance that the product is successful is 86%. 86 over 100, 0.86. And this is quite good. And surely we should launch the product. It looks promising. But we should also consider the financial outcome of our situation. The main problem with people usually is that they look at the probabilities only. They don't look at the financial. So if the product is successful, for example, we might make a reasonable profit. But if the product is not successful, for example, because there is still 14%, yes, remaining, we could stand to lose a lot more than we would gain under success. For example, the setup cost, advertising, production cost, etc. And such financial considerations could outweigh the high probability of success alone. So in real life scenarios, not only do we use probability to aid in decision making process, we also take into account the financial implications of our decisions. And this is achieved by weighing the probability of different outcomes by their value, which is often financial. So in this topic, we will not be focusing only on the P. We will not be looking at this only, probability. We will be looking at financial implications for us to decide. What are these financial implications? These are what we called as MV, our monetary value. Okay, so this is what we're going to talk about today. The monetary value, the financial implications, and we are going to calculate the EMV, expected monetary value. Then we can decide. So what is this? So the expected monetary value, or EMV, of the single event is simply the what? The probability of that event multiplied by the MV, the monetary value of that outcome. So this is the formula, because in some cases we have more than one event. So we have to add. This is the summation. Okay, because in some cases we have two or more events. If there is only one, so we're going to use only this probability and then the MV. That's it. Multiply both. That's the answer. But as I said, in most cases, we have more than one, two or more. So we have to add. Okay. Anyway, I'm going to give you examples later where We have more than one event. So it is the sum of overall possible events that make up the project. The expected monetary value can be used as a what? Decision criterion for choosing between different projects. It has applications in many situations. Okay, let's have one example. How to use this formula. This one. As I said, if there is only one event, we use this only. If there are two or more, we have to add all the events, multiply by monetary value. Okay, so number one, if you would win 5 reals if you pulled an ace from a pack of cards, what is the expected monetary value? And what is the conclusion? Yeah, in this type of problems, we have to conclude. It's not just about getting the value. Okay, so for example, this is a game. You're going to win 5 reals if you get ace. There are 4 aces. You remember? How many aces do we have? We have 4 aces. This one. We have the hearts, we have the diamonds, the clubs, and the spades. Yes? So all in all, we have 4. So the first step is to first identify the probability. So we have P of ace. I'll write it here. Equals, this is P, 4 over 52. And monetary value. This is our MV. Okay, it is positive because you're going to win. So win is positive, so positive 5. 5 Omani reals. If you're going to win, that means if you get one of the aces, there are 4 aces. So what is our expected monetary value? Use the formula. This is the formula above. This one. We have only one, so we don't need to add anything. 4 over 52 times 5. Okay, can you please give me the answer? What's the answer here? Did you get the same value? Guys, did you get the same value? Are you still there or what? What's happening?
Yeah, we got the same answer.
Okay, so you can round this one off to 3 decimal places because we have reals. Okay, so if this is pounds, you can round off to 2 decimal places. So this is 385, or we say 385 baisa. So what is the meaning of this? What is this 385 baisa here? Does this mean that you're going to win 385 baisa? What's the meaning of this? Okay, this value is not the amount you're going to get during that particular game. If you're going to play only once, or maybe you're going to play 100 times, no. 385 paisa is the average that you're going to have as a profit. Okay, if you're going to repeat this game a large number of times. So in other words, I mentioned here, if you repeated this bet is a game, a large number of times, overall, you would come out on average 385 paisa better off per bet. So on average, so this is 0.385 here, or we say 385 paisa better off per bet. So if you're going to repeat, for example, you're going to do this within 24 hours. Yeah, 24 hours you are playing. So on average, okay, you're going to get somehow like 385 paisa, like profit per game on average. But this is not, certain also. We are only getting the chance because we are using here our probability. So this is uncertain. But somehow we have an idea that if you're going to participate, most likely you're going to win if you're going to repeat this a large number of times. So assuming you are going to play for the whole night, and assuming that you played 100 times. So on average, you're going to get maybe 38.5 reals, 100 games. But as I said, this is only like our prediction. Yeah. So you are 0.385 better off per bet on average if you're going to repeat this many times. And another one is you would want to pay no more than. So that means if there is a payment per game, you have to pay around this value only, 0.385. So 385 paisa. So if the ticket is 500 paisa, it is fine. It's close to 0.385. If it is 1.5 reals, it's very expensive already. So this 0.385 here is the fair price, yeah, of the game. Because usually each game has a charge, right? You have to pay before you enter the game. So if you are supposed to be playing, you have to pay per ticket, for example, or per game, somehow close to this value, 0.385. So we are deciding here actually, So for example, this is the game. Are you going to join? Are you going to participate? Assuming that it is a yes or no only. So if you are supposed to decide, you have to say yes. Why? Because it is positive. So usually if the EMV is positive, we say yes, we are going to join. Because in the long run, it's going to benefit you. Yeah? Based on the given. Based on the scenario, it is favorable on our side. Right? It is favorable. Because it is positive. Did you understand this one? Did you understand what's the meaning of 0.38 something here? This is not what you're going to get during one game only. This is the average that you're going to get per game if you're going to repeat this game a large number of times. Okay, that means not just one time. Of course, if it is one time only, is only win or lose, right? Either you win or you lose. Because there are 52 cards and we are going to mix the cards. Of course, it could be an ace, it could be two, it could be king, queen. Yeah, but if you're going to repeat this many times, then for sure during the whole night you're going to win something because it's positive. Another one. Let's try to consider this bet. The first example is about 52 cards. How about if it is a die? Okay, you're going to roll a die. How many possible outcomes here do we have, guys? If it is a die, who can tell me? What is the possible outcomes? 1, 2. How many? Equals 6, right? Okay, so if it is a 6, you have to pay £5, for example. Okay, so 6 P of 6, there is only one. There is only one 6 there. So 1 over 6. And the monetary value, the MV, equals, you have to pay. So negative 5. If you're going to pay, it will be negative. Okay? The other one, if it is any other number. So any other number, what is that? Any other number is what? 1, 2, 3, 4, 5. Not 6. So we have 5 over 6. This is any other number. 1, 2, 3, 4, 5. Because the first event is, it is a 6. So there is only one 6 there. Any other number means 1 until 5. So 5 over 6. The monetary value is, you're going to receive. Receive is positive 2.5. So that means if it is a 6, you're going to pay £5. But if it is 1, if it is 2, 3, 4, 5, you're going to get or receive 2.5 pounds. Are you going to take on this bet? Would you take on this bet? Are you going to join the game? Justify your answer by solving for the expected monetary value. Now, we have two events. We have the event of getting a 6 and the event of getting any other number. So what did I say if you have more than 1? We're going to use what? We're going to use sum. Yeah? We're going to use the summation, sum. So that means that we're going to add 1 over 6. So our EMV, I will write here, 1 over 6 times negative 5, because you're going to pay, plus 5 over 6 times positive 2.5. Okay? Can you please tell me what is the value? This is the summation. That's why we have the plus. Okay, can you please give me the value here? And tell me whether you're going to join or not. What's the value, guys? Okay, what is the answer?
Is it 1.25?
Okay, very good. Okay, so what is our conclusion here? Okay, so you're going to say, I am going to take on this bet as it has a positive EMV. So positive, we just EMV. So if it is positive, usually we can join. So imagine, see, on average, if you're going to repeat this game a large number of times, you're going to get 1 real and 250 paisa if it is in real. In pounds, 1.25 pounds. Okay, so you're going to get 1.25 on average per game as your profit if you're going to repeat this a large number of times. So assuming we're going to roll the die for 24 hours, okay, and assuming you joined during the first 100 games or 100 rolls, so approximately you're going to get 125 reals as a profit during the entire game, 24 hours for example. As I said, this is not certain, but it is favorable on our part because it is positive. So in the long run, it is, favorable on your side. Okay, so this is how to decide using probabilities. We have to look at the probability, we have to look at the monetary value. Any question here? So in the test, you have to write your conclusion, follow the instruction. If I ask, would you take on this bet? You have to look at the EMV, and if it is positive, you're going to join. Don't say in the exam, I don't want to join because this is not a good game. I don't like to gamble, something like that. See, guys, we are just solving this problem. Somehow it is a game for us to apply this in many realities, in many scenarios. Yeah. So forget about religion whatsoever. Set aside, your beliefs and all. It's just, a game, and we are trying to calculate based on the value, and based on that we decide. Okay. Okay, let's have number 3 now. National lottery. This is very common in America. In UK, in Philippines, we have this lottery where you're going to get a prize. Prize. Prize is it's like the award. Okay. So assuming that you will have these prizes when you match these balls, assuming that the balls are from 1 to 49, if you get 6 balls exactly in any order, you're going to get 4,894,097 pounds. Assuming that you're going to match 5 balls plus the bonus ball. The bonus is given by the company. Okay. 390,000 only because only 5. Exactly 5 balls match, you're going to get 2,000. By the way, many people are becoming millionaires because of this lottery. especially in UK, because the prices are very, very high. If you're going to match 4 balls, 164. If you're going to match only 3, 25. If you're going to match less than 3, that means 2 balls or 1, you are not going to get anything because, of course, it's very high, 98%. So 98% of the people usually will be getting less than 3 balls, like 2 balls or 1 ball. So assuming that the winning balls are 2, 45, 3, 9, 10, and 15. For example, these are the winning balls for today. 1, 2, 3, 4, 5, 6. Assuming in your ticket, you bought a ticket today and you have these numbers. In any order, you are going to win this amount. You become a millionaire, 4,894,097 pounds. Because you match 6 balls exactly. 45, 9, 10, 2, 3, and 15. In any order. This is also an example of combination. Yeah, because we don't care about the order. As long as the balls are matched, that's it. Okay, so this is the scenario. If you're able to match 6 balls completely in any order, you're going to win this amount. But look at the chance. Very, very less. Why very less? There are 49 balls. Yeah. Sometimes they have 46 balls, but usually until 49 balls. So it's not easy to get 6 balls exactly. So very less. 0. There are 7071. And this one is very high, 98% point something. Because what? Less than 3 balls only you have to match. For example, 2, 45, 3, 9, 10, 15 are the winning balls. You match, for example, 10 and 15. You don't get anything because you did not get 2, 45, 3, and 9. If, for example, you match 3 exactly, for example, you get 2, 10, 15, you're going to win 25 pounds. 3 balls. Okay? So, the higher the number, the higher the prize. Okay. For example, these are the probabilities. And these are the prizes. So this is our MV column. PRIZE, the price, that is our monetary value. Okay, MV. And this is the P of event. Remember our formula? This one, P of an event. These are the probabilities, which are given already. So let's solve. Okay. So you have to multiply 1 by 1 and then add. You know the formula. So 0.0071 times 4 million. Okay, you press equals plus. Why equals? Because we have so many digits there. There is no space in the calculator. So every row, press equals and then plus. Continue. 429 times 390, 643. Okay, 390, 643 equals and then plus again. You continue down until the last. This one no need because it is 0. It will not change. Can you please give me the answer? Use your calculator. Okay, what is your answer, guys? What is the expected monetary value? It is 1 point something. Did you get this value? Okay, let's say 1.16. So this is the answer for number 1. That is the fair price. So EMV is also called as the fair price. Price. Okay, that means this is the fair price for a ticket in this particular lottery. And usually companies will be adding more. We call that one as margin to get some profit. Okay, because they will keep also on updating this. 4894, if no one wins during a particular week, they are going to add some more values here. They keep on increasing the prices. So for example, number 2, if the standard charge or price for a ticket is £2, find the difference between the standard price and the fair price per ticket. So this will go toward the £1,000,000 raffle. So the difference will be what? Because they're selling the ticket for £2. So 2 minus 1.16 equals 0.84. So somehow in reals, assuming that we are selling the ticket for 2 reals, so we have a margin of 0.84. So that's like 840 paisa per ticket. So assuming that we sold 1 million tickets. For example, we sold 1 million tickets during the week. Okay. 1 million people, for example, bought tickets. What is our profit somehow? We are getting 840,000 because this is times 0.84. So this 840,000 will be added here. Will be added to the prices if no one wins during that particular week. Yeah, so this is what they're doing actually. Whatever is the total amount accumulated, the difference because this 0.84 is the difference per ticket. This is per ticket. Every ticket, they're getting like in reals 840 paisa. 0.84 Omani reals. Okay, so in pounds, it's like 84. Yeah, 0.84. Because they're using 2 decimal places only. Do you have any question here? Did you understand this one? Guys, did you
Yes,
understand?
Mister. Yes.
So the fair price, that is your EMV, that is the price of the ticket. And usually, as I said, companies will add more and that will become the standard price. So the difference, usually they're going to use it for some other purposes. It could be for other projects, or it could be additional amount for the prices. So price is different from price. Yeah, price here is the award. Yes, or we call this as reward specifically. We talk about a lottery. So we are done with this. We will now proceed to decision trees. When is your prayer time? Guys? So let me proceed to the decision trees.
Welcome to this decision analysis tutorial. Welcome to this decision analysis tutorial for constructing decision trees. We will be constructing a basic decision tree. We will also be making decisions using the expected value approach. We will be constructing a decision tree using this payoff table, where payoffs are profits and the probability of the states of nature are zero point 0.4 and 0.6 respectively. Decision trees use two types of nodes: a square or rectangle node called decision node, from which decision alternative branches will originate, and a circle node called chance node, from which states of nature or outcome branches will emanate. The chance node is also referred to as an outcome node or event node. Now let's construct a decision tree for this payoff table. We first draw a decision node with branches coming out of the decision node representing decision alternatives. Next, we draw the chance node or outcome node with respective states of nature or outcomes, as it can be seen here for stocks. The payoffs are placed at the end of the branches, as you can see, 70 and -13 for stocks. We do the same for mutual funds and for bonds. Notice that the payoff is 20 for bonds, irrespective of the state of nature. Therefore, we really don't need to repeat 20. We simply need to draw a single branch from bonds with a payoff of 20. Now let's solve the decision tree. Solving the decision tree is also known as folding back the decision tree. In essence, we are going to calculate the expected values and then choose the best. For stocks, the expected value is calculated as 0.4 times 70 plus 0.6 times -13, which is 20.2. So we just usually write the 20.2 on the chance node for stocks. We do the same for mutual funds. The expected value is 0.4 times 53 plus 0.6 times -5, which is 18.2. We also write that on the chance node for mutual funds. For bonds, no calculation is required. We can only expect a payoff of 20 for bonds. Now, comparing the three values, 20.2, 18.2, and 20, the best expected value is 20.2. We usually just place that value close to the decision node. Therefore, the decision is to invest in stocks. Thanks for watching.
Okay.
Feature or
So
outcome
here
branches will emanate.
we have the circle and we have the rectangle or square. The rectangle or the box will be our decision node. So what follows after this will be the alternatives or the options. The circle is usually for the probabilities. So after the circle should be your probabilities. So in this particular exercise, we have 0.4 and 0.6. The total should be equal to 1 if it is in decimal or fraction. If it is in percentage, it should be 100% all in all. Okay, so these are the alternatives, the stocks, mutual funds, and the bonds. Okay, so for the stocks, we have either growing or declining. Growing is positive, declining is negative. Okay, so we have 70, negative 13, and the second one, MF 53 and negative 5. Bonds 2020, so the same, so the value will be also the same because 20 and 20. So as I said, this is the decision node, this is the chance node, or we call this as the event or the outcome node, our circle, because this is for what? Probabilities. So the chance, outcome, event. So here, as you can see, after the box, after the rectangle, we have our alternatives. So always don't forget this one. So we have three alternatives. So we have three lines. And as I said, after the circle will be our probabilities. We have two, the growing and declining, 0.4 and 0.6. The total is 1. And we put our values here on the right, 70, negative 13. So don't be confused in the exam. 70, negative 13. And we just copy paste this. See, growing, declining, growing, declining, growing, declining. We just copy paste our what? Probabilities for every option, for every alternative. And we calculate, you multiply 70 times 0.4, the 0.6 times negative 13. We put the value here above and we compare later. So we have three expected monetary values, the AMV for the stocks, for MF, and for bonds. And we compare. So towards the end, we see that the highest is 20.2. So the decision is to invest on stocks. Okay, so let's have another example. Guys, do you have any question? Did you understand the video? Is it your prayer time now?
Yes, Mr. The break time now.
Okay, so we will continue when you come back. You come back at 7:05.
Okay, Mr.
Okay. Hello. Can you hear me? Hello. Okay.
Yes, we can hear you.
Okay, let's continue. Let's now have the decision trees. As I said, you have to use a rectangular node for decisions. And there are no probabilities at a decision node. So for the box, you have to use only this for your options or alternatives. And the circle is for the probabilities. Okay, let's have this problem. Synaptic is a small technology company with a new and innovative product that they wish to launch onto the market. So it has three approaches. It could go for a direct approach or internet. The other one is licensed to a larger company. So direct approach means launching onto the whole of the domestic market through traditional distribution channels. That means through the stores, traditional method. Or it could use the power of the internet to advertise its products, launch its new product. The third option is using another company. Usually companies use a third party to promote their products and services, right? So they have to pay a license fee irrespective of the success of the product. So whether it is successful or not, they have to pay the license fee. So there are three approaches, either direct approach, direct, we have internet, or license. The company has done some initial market research, and the managing director, Jack Holmes, believes the demand for the product can be classed into three categories. It is either high demand, medium demand, or low demand. Jack thinks that these categories will occur with probabilities 0.2. That means for the high demand, 20%, or 0.2, medium is 0.35, and low is 0.45. Respectively, you know what's the meaning of that? It means that high is 20%, 0.2, medium is 0.35, low is 0.45. The total is equal to what? Total is what? The total, as I said, should be always equal to 1 or 100%. So 0.2, 0.35, and 0.45 is equal to 1. So these are in K. That means 1,000. So this is 100,000, 55,000, negative 25,000, 46,000, 25,000, 15,000, 20,000. Okay, so all of these are in thousand. K. K means kilo. Kilo means 1,000. Okay, so we have three options. Now, how should a company launch the product? Justify your answer by calculating the expected monetary value using a what? Decision tree. So this is what you're going to do in the exam. The problem will be given to you, and based on this, you have to create a decision tree like the one in the video a while ago. Okay, so you have to focus on the probabilities, of course. That will be after the circles. Now, you can define the variables You can have H equals high to minimize, to save space. M is medium. You can do this in the test, okay? L equals low. All right, so we have to start with our box here, our rectangle. This is your first step always. Okay, so please remember this in the exam. The first step is to create a box, rectangle, square. Now we have three approaches. So we are going to have three lines. Okay, so this one is for the direct. Okay, this is for the internet. And the other approach is the license. Okay, then you will have your circles. As I said, these circles will be followed by the probabilities. We have three: high, medium, and low. So let's have it here. Okay, so I can use H 0.2, medium 0.35, and low 0.45. Here the same, you have to copy paste only. High, medium, and low. And here we have again 3. Okay, so here I have my high 0.2. This is the medium and low. Okay, so the table is given. You follow the table. We have 100. We have 55, negative 25. Here we have 46, 25, 15. Here there is no need to solve because the same. So the answer here will be 20K for the license. Let us calculate for the direct and internet. Can you please calculate? 0.2 times 100 plus 0.35. Okay, give me the value. 0.45 times negative 25. So what is the expected monetary value here? The other one is 0.2 times 46, 0.35 times 25. Okay, so this will be 28K. And this will be here 24.7. Guys, did you get the same value? Can you please check? Okay. What is your decision? You have to write your decision in the exam. Go for the direct
Direct.
approach, as it has the highest EMV. So in the exam, you have to write your decision. Okay, do you have any question here? Did you get it? Okay, let's proceed to the next. Okay, your homework is number 5. Please try this one. Okay, this is on move page, example number 5. Please try. Okay. This one, exercise 9. Go to example number 5. Okay, go down. This one, example number 5, exercise 9. We will now have exercise number 10. We'll start with problem 1. The file is there on move page also, this one, exercise 10. Okay. Let's start with problem 1. Imagine that you have watched people playing a fruit machine in a certain pub, and you have noticed that over a long period, it gave 5 reals payout on average every 20 turns. Are you going to join? Are you going to play? Is it worth your while playing the machine? If the charge per turn is half real, 500 paisa. So we will have to break this one down. So assuming that you are just observing, okay? Observing the people, watching the people, they're playing a fruit machine. And this fruit machine, every game is 500 paisa. They have to pay to play the game. And you notice that over a long period, okay, because it should be repeated, a large number of times, 5 reals pay out on average every 20 turns. Is this game okay? Are we going to join? Let's see. Before we can say that, we have to calculate. First, let's start with winning. Winning is, see, per 20 every turn, every. So 1 over 20. And the monetary value is 5 reals. So that means people are getting 5 reals every 20 turns on average. So you are just observing and you notice that people are getting 5 reals every 20 turns on average. So that will be 5, okay, minus 0.5. The monetary value. Why? Because this is the charge. Assuming that you win, you are not going to get full 5 reals during that time. You're going to get only 4.5. Why? You're going to get 5, but you paid 500 during that time. 500 paisa. Yes? So the monetary value is only 4.5. How about losing? If winning is 1 over 20, what is losing then? What is the opposite? What did I say a while ago? 1 minus the opposite, winning. So this will be 19 over 20. And the monetary value, if you lose, you don't get anything, but you pay 500 paisa. Negative because you pay. Yeah, this is the charge. This is the charge. So negative. Same here, negative also. Okay, so now let's have our expected monetary value. As I said, we multiply times 4.5 plus 19 over 20 times negative 0.5. Okay, who can give me the value? What is the answer? Guys, what's the answer here? Negative what? Okay. Our conclusion here below. You have to write your conclusion. It is not that means you don't need to play, or you don't have to play here. Why? Why we don't need to take this bet? Why we don't need to play this machine? Because it has what? Did you get the same answer, by the way? Did you get the same? So it's not, huh?
Yes, mister.
So it is negative. So that means in the long run, you are most likely to lose. Yeah, if you're going to repeat this game large number of times, most likely you're going to lose because the expected monetary value is negative. Of course, if you're going to play one time, so it's only win or lose. Maybe you win, maybe you lose. But if you're going to repeat, for example, over a long period of time, it's also mentioned here. Assuming that you're going to play, for example, 100 times. Yeah? If you're going to play, for example, 100 times on average, you might be losing 25 reals. Yeah? Because the expected monetary value is negative 0.25. So let's say you play for 10 hours. And during this, hours, you played 1,000 times, for example. Okay? So most likely you're going to lose 250 reals. Most likely. Based on this expected monetary value. Because negative 0.25 times 1,000. Somehow. Okay? Is that clear? So if the value is negative, then you might say this is not worth, playing the machine because it has a negative expected monetary value. Because if you're going to repeat this game a large number of times, most likely you're going to lose. All right, let's go back again to decision tree. How many alternatives do we have here? How many alternatives? Guys, we have 2. So the first step is to draw the box. Okay, and you will have 2 alternatives. One is abandon. Very simple in your exam, yes? If you know the technique, very, very simple. Go ahead. So you can define some variables. Here you can have SA, series appears, and NS equals no series. These variables, and RM, rival market. Okay. And NR, no rival. Okay, this ones. This is to save space. So here we're going to have our circles. So we need only 2 circles because we have 2. We have 2 alternatives, abandon and go ahead, and we have 2 probabilities. So we need only 2 lines here. Yeah, a while ago we had 3 lines. So first is series appears 60% and no series is 40%. Total is 100%. So this is negative 5K. So we don't need to solve. The answer here is directly negative 5K. Now we have to copy paste this SA 60%, same. Okay, and NS the same, 40%. For NS, we have the value negative 1K. But here we don't have the values. We have another set of probabilities, 50%, 50%. So we have to draw again another circle and draw 2 lines. Why 2 lines? Because we have 2. For rival markets, 50%, and NR also 50%. So this is 11K, and this one is 19K. So we cannot solve this immediately without solving first the outside. So what you're going to do, you multiply 0.5 times 11 plus 0.5 times 19. So this will become 15K, right? Because 0.5 of 11 plus 0.5 of 19. Now we can solve 0.6 times 15K plus 0.4 times negative 1. Okay, we can now solve. This will become 8.6K. Okay, so what is our decision? Go ahead. Yeah, it has a higher. We use higher because there are 2 only. If 3 or more, we say highest. Okay. Do you have any question here? Any question here? Did you get it? Okay, so this one is your homework. I want you to practice on this so you'll be able to master the concepts. Please practice. First, look at the probabilities and look at the alternatives. Here we have 2. Here we have 3 alternatives, X, Y, Z, and also we have 3 probabilities. Here we have only 2 and we have 2 probabilities. Okay, so you try this one, and for this you will be able to master everything. Okay, all the answers are here. See, please look at these answers later. Okay, the title is Decision Making Using Probabilities. So all the answers are there and all the questions. Homework is there. This is the video. You can watch this one again during your free time, or you can go to YouTube and type decision tree. So you will learn more. So just go to YouTube, for example, and type this one. Okay? Many examples there. This one is good.
Company must decide what.
All right, so I want you to check some other videos during your free time. Let's now have the permutations and combinations. Okay, what is the difference between the two? Actually, permutations are combinations, but they are special combinations. So what is combination? Combination and permutation exist in real life. And usually we use the word loosely without thinking if the order is important or not. So actually in combination, we don't care about the order. Example is fruit salad. Combination of apples, grapes, and bananas. We don't care about the order. It could be bananas, grapes, and apples, or grapes, apples, bananas. The flavor of ice cream, for example, when you go to Baskin Robbins, for example, you don't care how they are being arranged, right? In your paper cups. That is example of combination. But how about combination to the safe, the password? For example, 472. We do care about the order. Because if you're going to rearrange, for example, 724, 247, this will not work. It has to be exactly 472. Another example of permutation is your PIN code for your ATM. That is permutation. Why? Because it should be exactly in the same order. If your password is 5192, that should be 5192. You cannot change that. Your student number. Student number is an example of permutation. For example, your student number is 2012564. You cannot rearrange this. That should be your number. If you're going to transfer 6 here, in the beginning, it will not work. Plate number of your car, for example. Yeah, you should follow the plate number. Your name also. Yeah, the letters of your names, unless otherwise, you know, we made a mistake in writing your name. Yeah. So even our name is an example of permutation because we have to follow exactly how the letters are being formed. For example, Albert. I cannot change E and R. It will become Albert, for example, right? This is different. So I have to follow exactly ALBERT. So when we say permutation, this means that the order does matter. Combination, the order does not matter. So permutation is special combination. It is an ordered combination. So always remember that the starting is P, so position. Position is very important when we talk about permutation. For example, if the password is 5166, the position of these digits should be followed. 66 no problem because they are repeated. But 51, you cannot write 1566. This is a different password, right? Same with the password you are using for your move page. Move page, for example, you are using what? Your password, username. All of these are examples of permutation because the position is important. Now we have two types. One is repetition is allowed. The other one is no repetition. Usually our password is an example of permutation with repetition because we are allowed to repeat the digits. For example, 333. Or maybe NBO is going to give you this password 5099 for your ATM. We are repeating some digits. That is what we called as permutation with repetition. The other one is no repetition. For example, the first three people in the contest running race. You cannot be the first and second at the same time. Yeah, you will get only one rank. It could be that you are the first or second or third. We cannot say that Mr. X is our first and the same time our second. That will not happen in real life, right? It's not possible for one person to have two ranks in the contest. So let's have first the easiest one. The easiest one is permutation with repetition. This is what I'm talking about here, that we are allowed to repeat some digits, some elements. For example, we have 0 to 9. There are 10 elements. So the number, the total number of elements, that will be your n. Yeah, total number of items. Now, how many items per permutation, per group? That is your R. Okay? How many items per group? So for example, we have 0 to 9 and we're going to choose 3 only. For example, 1, 2, 0, 1, 3, 3. We are allowed to repeat 5, 5, 5, 6, 7, 9, 1, 2, 8, 2, 2, 5. These are examples. Okay, as you can see, every group has 3 things. So that is our R. R is equal to 3. I hope you understand the meaning of R here. This is the number of items per group. And from where we're getting this? From this 0 to 9, 10. So the formula is very simple. If repetition is allowed, n raised to the power of r. So it's very, very simple. So we have 10 raised to the power of 3. There are 1000 permutations. And these are some of these. 1, 2, 3, 4, 5, 6. So we still need 994 permutations. So it's difficult to write all of them. So usually in problems like these, we identify the number. Usually we don't write all the permutations. We want to know how many. And we can have some examples like this. These are 6 examples of 1000 permutations. So if we're going to write all, maybe it's going to take 1 week to do that. Yeah? Because 1000 permutations. All right. So that's very easy. Let's have another example. Please remember the formula. Guys, are you still there? Are you listening to me? Guys, are
Yes,
you listening?
Mr.
Okay.
Yes, Mr.
Okay, so the formula is very simple. N raised to the power of r. Here we have x, y, z. So what is our n? N is what? 3. So find the number of permutations. Choose 2. 2 elements. Each permutation contains 2 elements. So our r is equal to 2 because we are going to choose 2 elements. And from where? From x, y, z. So we have n raised to the power of r is equal to 3 squared, 9 permutations. Okay, so you have to list all of them. In some cases, we can list if we have small number like this. Here is not possible, although it is possible, but it's going to take our time. There are 1000. Here we have 9, so we can write all. So let's have here our list. Right? Who can give me the first one? X, Y. Yeah, we have 2. X, Z, Y, X, because X, Y, Y, X different. Y, Z, Z, X, and then Z, Y, X, X, because we are allowed to repeat. Y, Y, and Z, Z. Okay, so there are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the meaning of this. Okay, and we have 2. So we choose 2. All right. Do you have any question here? Okay, let's proceed to permutations without repetition. We are not allowed to repeat. Okay. For example, here we have 16 balls. Okay, and we rearrange them. We are not allowed to repeat again. For example, 1 is on this part, so that will be there. Yeah. And then 14, 10, we are not going to repeat it again because there is exactly 1. 1, 1, 1, 14, 1, 10, 1, 3, 1, 16. Now, how about if we are just going to choose 3 of them every time? There are 16 balls. Example is 16, 1, 2. Or it could be 14, 15, 16. We choose 3. Or 1, 2, 3. 9, 8, 15. These are the examples. So how many ways? We are not allowed to repeat. As you can see here, 16, 1, 2, no repetition. 14, 15, 16, 1, 2, 3, 9, 8, 15. This one is not allowed. 1, 1, 10. Because 1 repeated. Okay? So you are not allowed to repeat any number. So it's very simple. Okay, descending. Start from the total number. Multiply by that number minus 1, then minus 1 again. So this is the first peak, second peak, third peak. As you can see, it keeps on decreasing because we are not allowed to repeat. Yeah. So as you can see here, it is not decreasing. 10 times 10 times 10 the same, because with repetition we are allowed to pick again the same number. So 10 times 10 times 10, 1000. Same here, 3 times 3 equals 9. We are not repeating. I mean, we are not deducting by 1. Okay, we are not deducting by 1. This is 3 times 3 equals 9. 3 squared. Here we are deducting by 1. 16 times 15 times 14. Because without repetition. So this is about factorial notation. We are decreasing by 1 until we reach 1. For example, 4 factorials. 4 times 3 times 2 times 1, 24. 7 factorial, 7 until 1, 5040. 1 factorial is 1, 0 factorial is 1 also. So it looks funny. 0 factorial is equal to 1. Later I'm going to explain this in detail why. Okay. So 16 factorial is equal to this. This is if you're going to select 16 balls in every group, but we're just going to select 3. Choose 3 only. These are the examples. 16, 1, 2, 14, 15, 16, and so on. So what happens there? The remaining 13 until 1 gets cancelled. So the formula is n factorial over n minus r factorial. As you can see here, 13 times 12 and so on gets cancelled. So it means that n minus r factorial below. So instead of multiplying like this, 16 times 15 times 14, we can use the formula. The formula is n factorial over this whole quantity. So in the calculator, okay, you type 16 and then shift. We just erase this. Okay, 16 and then shift x, this one. So when you press this, you're going to see this like exclamation point. And then divide 13, shift the same, you're going to get 3,360. So why we are using the formula when we can multiply 16 times 15 times 14? Same answer. See here? But why do we need this formula above this one? Because in some cases, there are very large number of items. For example, when I say 5,000 items, for example, and then choose 182. Are you going to use this method? That means 5,000 times 4,999, 4,998, and so on. 182 times. When you're going to finish? You're going to finish tomorrow. So the best way is to use the formula. If the total number of items is very large. In the exam, if it is only 16, 20, you can use this method. Okay? But if it is very large, you cannot use this method, properly. Although it's possible, but it's very time consuming. So you have to use the formula. Another example. How many ways can first and second place be awarded to 10 people? So we have total number of items 10. That is our n. So the formula is here. So this is our n factorial. N, so 10 again, minus r. 2. Why this is 2 here? Can you please explain to me why this one is 2?
Maybe is it because they said first and second place?
Yes, because we have 2 places. 2 positions, first and second place. If I say first, second, and third, 10 minus 3. So the answer will be 90, or you can use the manual method. During the first pick, it will be 10. This is the first. This is the second. As you can see, minus 1. 10 times 9 equals 90, which is exactly the same here. 10 factorials divide 8 factorials. So this method is applicable because very less, only 10. Yeah, how about if I say 1,000 people and then we say, for example, first until 9th. First, second, third, fourth, fifth until 9th. It's difficult. So we have to use the formula. So there are many symbols, this, or this. All of these mean the same. So we can write like this: P open 10, comma 2, close, 90. So P here is permutation. Okay? Is this clear to everyone? Did you understand?
Yes, mister.
Okay, let's now have combinations. One is repetition is allowed. For example, your coins in your pocket. We don't care about the order. It could be 5, 5, 5. 5 baisa, 5 baisa, 5 baisa, 10 baisa, 10 baisa. And no repetition. For example, in lottery, we are allowed to change the position, but we don't repeat any number. This is combination without repetition. So an example of this is lottery. Yeah. Another example is this one, 1 to 16 balls. So the most difficult one is combinations with repetition. So let's start with combinations without repetition. The formula is very simple. It's like this formula here, but we're going to put r factorial outside. Okay? So the formula will become like this. This is combination without repetition. We don't repeat any object. For example, this one is permutation. Why this is permutation? Because 1, 2, 3 is different from 1, 3, 2. It's different from 2, 1, 3. But in combination, it is only 1. It can be 1, 2, 3. It can be 3, 2, 1. They mean the same thing. It can be 2, 3, 1, 3, 1, 2, 3, 2, 1. This is only one in combination. Yeah, without repetition. So the number becomes smaller. So the number of combination is usually smaller than the number of permutation. Here, only one. 1, 2, 3. Here there are 6 in permutations. So 6 times is mentioned here. So usually the number of combination is less than the number of permutation. Why? Because the position is important in permutation. So every time we change the position, it changes the meaning. It changes the value when it is a number. But in combination, it means the same thing. So these 6 numbers mean only one in combination. So that is why we add r factorial outside. Okay? So please remember this formula. This one. Same with permutation without repetition, but there is r factorial outside. So these are the symbols. You can use this or this. Direct. Okay, and choose r. This is the formula. All right. This one we're going to use later. R plus n minus 1 factorial. Divide r factorial times the quantity of n minus 1 factorial. This is combinations with repetition. An example of these is this one. Coins in your pocket or coins in your wallet. We allow the repetition and order does not matter also. So the formula becomes more complicated. So let's have some problems. And we apply these formulas. Okay. So number 1, how many 3-digit numbers can you make using the digits 1, 2, 3 without repetitions? The first problem, is this combination or permutation? 3-digit numbers. Is this permutation or combination? So whenever you solve problems involving this combination and permutation, first step is to identify whether it is permutation or combination. When we say numbers, it is permutation. Okay? So using this 1, 2, 3. So our n is equal to what? N is equal to 3. Or we can multiply directly. 3 times 2 times 1. Because very, very small. N is 3 only. So decreasing. 3 minus 1, 2. 2 minus 1, 1. So the answer is 6. Or you can use the formula n factorial over n minus r factorials. Okay, so your n is 3. And then here 3 minus 2. 3 minus 3. Because 3-digit numbers. So it will become 3 factorial over 0 factorial. Why 0 factorial? Because 3 minus 3. So 3 factorials means 3 times 2 times 1. That will be equal to 6 also. Divide 1. So equal to 6. So you can use the formula in the test, or you can use directly this method because very, very small n. N equals 3. Okay, number 2. How many different words can you make? See, words. Words also permutation, because every time you change the position of the letters, it changes the meaning, right? So also permutation. So how many? A, B, E, L. So how many different words can you make using the letters A, B, E, L? There are 4, right? So 4 times 3 times 2 times 1. So the answer will be 24. Why? Because we are going to use, see, 4 times 1, 2, 3, 4, because we are going to use the letters every time. So it could be Bella. Yeah, it could be B-E-L-A. So we use 4 letters, we just rearrange. Or it could be Ebal. Yes? It could be something like Bale, Balle, or Leba. These are examples. So we keep on going. There are 24 all in all. If we keep on going, writing all. But we don't need to write all because the question is how many. So there are 24 possibilities using A, B, E, L. So these are examples. Bella, Ebal, Bale, Leba. Okay. Or you can have L-A like this. Labe. With or without meaning. Okay. Did you understand number 2? Number 3. How many 2-letter combinations you can make using the letters X, Y, Z, M, K without repeating the letters? So what is the formula without repeating the letters? Who can remember the formula? N factorial over what? R factorials, N minus R factorials. So equals how many? X, Y, 1, 2, 3, 4, 5. So 5 factorials over, we're going to choose 2 letters. So 2 factorials, 5 minus 2 factorials. Okay, times 3 and so on. Dot, dot, dot. This is 2 times 3 and so on. Because 5 minus 2. So this will be cancelled. So the remaining is 10. Yeah, 20 divided by 2. So that is the answer here. 10. Do you have any question there? Because see here, it is 5 times 4 times 3 times 2 times 1. That is 5 factorials. And below, 2 factorial is 2 times 1. And here 5 minus 2 factorial means 3 times 2 times 1. So this will be deleted. So the remaining is 20 divided by 2 is equal to 10. Okay? Number 4. How many 4-digit password? Password is permutation. Repetitions are allowed. Okay. And how about if repetitions are not allowed? So our n is equal to 3. Our n is equal to 10. This is number 4. And our r is equal to 4. Because we have 0 to 9. So repetitions are allowed. That is 10 raised to the power of 4 because the formula is this. So that will be 10,000. This is for the first one. Repetitions are allowed. How about if repetitions are not allowed? What is the formula? N factorial over n minus r factorial. Okay, so this is 4b, this is 4a. We have two answers in number 4. So we have 10 factorials over 10 minus 4. Okay, so that will become 10 factorials over 6 factorials equals 5040.
Mr. Can I ask you a question?
Yeah,
Um, so you said that formula without that formula that repetition is allowed. Oh no, it's not allowed. It is okay. Isn't it same with third question?
okay. Number 3,
Yeah,
the formula is like this. This is the formula.
yeah.
Mm.
Isn't it formula that for the repetition, no, combination that repetition is are not allowed?
Yeah, this is a combination without repetition.
Oh, then isn't it same with number 4 questions and the second question?
No, number 4 is about password. Password is permutation.
Ah,
Yeah. Number 3,
yes.
I mentioned combination. Number 4
Yes.
is password. Password is permutation.
Yes, yes.
Yes. So
Thank
we
you.
use this formula. N factorial, there is no r outside. There is no r factorial outside. Okay?
Yes. Yes, Mr.
Okay, let's have the last problem there. All the answers are here. Okay. How many different ways can the letters of the word mathematics be arranged? So before we solve that, let's watch this video.
In this video, we are going to learn about permutations with repetition. First, let's remember what a permutation is. A permutation is an ordering or an arrangement of certain objects. And often, permutation problems will ask you in how many ways can you pick and arrange a certain number of objects from a larger set of objects. But what happens when some of those original objects are the same? Now, these sorts of problems are permutation problems with repetition. And these problems will often take the form of a word that has some repeated letters, and you're trying to figure out how many words can you make from that original word. So for example, what if we had the word Mississippi? This is an 11-letter word, but some of the letters are the same. Notice that we have 1, 2, 3, 4 different I's. We also have 4 S's and 2 P's. So if we wanted to think about how many ways could we rearrange the letters in the word Mississippi to make other sort of words, we couldn't just say, oh, that would be 11P11, because we have 11 letters, we're picking and arranging 11. The reason why is because we would end up counting some words twice, because there's no way to tell the difference between, for example, the P's. Okay, if I switched the place of these two P's, it would look like exactly the same word. So we would be counting things multiple times. So the way to get around that is you start out with doing your original permutation, which would be 11P11 in this case, because there's 11 letters and we're trying to rearrange them. So we're picking 11 of them to rearrange. We're going to take that and divide by the number of ways to rearrange each of these sets of letters that there are multiples of. Okay, so how many ways can we rearrange 2 P's? Well, in 2 ways. In general, it will just be the number factorial. So for the P's, we're dividing by 2 factorial. For the I's, there are 4 I's. We're dividing by 4 factorial. That's because there are 4 factorial different ways to rearrange 4 I's or 4 of any object. And we want all of those 4 factorial ways to only count as 1, because we won't be able to tell the difference since all 4 of the I's are the same or look the same. And same thing for the S's. So again, divide by 4 factorial for the S's. So for the I's is 4 factorial, and for those S's, because there's 4 S's, we're also dividing by 4 factorial. And now we just need to compute this out in order to figure out how many words can we make from the word Mississippi. So to do this, one way would be to write out 11P11 as multiplication, and so that we can start maybe canceling things. You could also use your calculator to do all of these calculations as well. So I'm just going to use the calculator, and 11P11 is a big number, 39,916,800. And we're dividing that by 2, because 2 factorial means 2 times 1. And then 4 factorial, which is 4 times 3 times 2 times 1, which is 24. And then dividing by 24 again. And we end up with 34,650. So because there are all these repetitions in the word Mississippi of letters, there's not millions of ways to rearrange to make new words. There's actually only thousands of ways, 34,650. So again, the way you do this is think about as if there were no repetitions first. So 11P11, because there are 11 letters and we're going to pick all 11 of them to rearrange. Then look for any repetitions and divide by the number of letters that are being repeated factorial. So for the P's, there were 2 P's, so it was 2 factorial. There were 4 I's, so that was 4 factorial, and 4 S's, so that was 4 factorial.
Okay. So here we're going to apply the same thing. The formula is n factorial over the identical elements, n1 factorial, n2 factorial, and so on. So for mathematics, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So we have 11 factorials. So first is 11 factorials divide. So 11 is the total number of letters, including the repetition, of course. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So m is repeated 2 times. So we have 2 factorials. How about a? 2 times. Okay, times t, 2 again. Right? So m, a, t repeated. H, no, e. So we have only that. Can you please give me the answer? 11 factorials over 2 times 2 times 2. Because 2 times 1, 2 times 1, 2 times 1. Did you get the value? This value?
Yes, I got this.
4989600. So this is actually permutation where there are some identical elements. Permutation involving identical elements. What's the meaning of identical elements? We have some elements which are repeated in our given number of things. So mathematics, m is repeated, a repeated, t is repeated. So we have to count how many m, so 2. How many a, 2. How many t, 2. So 2 factorials. H, E, I, C, S, these are not repeated. Okay, so we will start with our revision next week. I'm going to include this one. I'm going to give an example of this. Combinations with repetition. Because we don't have time. And we will start with our revision. And you start watching this video. This video is about linear programming. Okay, that is the last. So I want you to watch the videos. There are 2 videos there about linear programming. This and this. And in the revision, I'm going to include 1 problem about linear programming. Okay, so don't be absent next week. We will have the revision 23 and your exam will be 26 and 27. 26 will be only 30 minutes. That will be computer based. It's like online quiz, multiple choice, and 27 will be take home exam. Okay, so don't be absent on Sunday.
Mister, so next week, Sunday is revision?
Yeah. Revision.
And then 27 is exam, right?
26, 27.
Twice?
Yeah, one is computer based, 30 minutes, multiple choice, and 27 will be take home exam. Okay?
Oh. So, but topics are mixed, right?
Yes, from topic 5. Topic 5, 6, 7, 8. That will be
With
multiple choice. This one. 5, 6, 7, 8. That will be May 26, multiple choice like this. Like this one. This one. You
so
know
from
this one, right?
all the lessons we learn, right?
No,
Topics are
from
not
topic
divided.
5.
Yeah.
From topic 5.
Till what we learn today.
Yeah, including today. Until here.
Yep, the not leading programming.
Yeah, programming is for the take home. This is for the take home exam. Okay.
Then do we take the programming, only programming in our home exam?
No, your take home exam will be from topic 5. Topic 5
Yeah.
until linear programming. Your multiple choice will be from topic 5 until topic 8.
Yes, I got it.
Yeah.
Yep.
Okay, so is that clear to everyone? Can I leave you now?
Have a nice
Mister?
day, mister.
Yes, have a nice day. How about others?
Mister,
Yes, Osama.
and the exam just topic 8?
No, no.
Only topic 8?
Topic 5, from topic 5.
Okay. Topic 5.
From topic 5 until topic 8 is your multiple choice. 30 minutes.
Okay. Okay,
Take home exam also from topic 5. Okay.
okay, Mister. Thank you.
From here, you have to start from here. Topic 5. Okay.
Okay, Mister.
Okay, bye.